The surface area of a pyramid can take a lot of different formulas to cover. The important thing to remember is that surface area is figuring out how much material I need to cover every surface of a shape, this back too. So it's really dependent on what your base is. Okay, so like this one has a triangular base, so the base would be one side we need to cover, and then it has these three sides, one in the back here, that we need to also worry about. So total, this pyramid has four sides that we would need to make sure we account for. Whereas this one has a rectangular base, so we've got that to cover. And then, of course, because of that, we've got four lateral sides for a total of five sides. So oftentimes I would just think, count up the number of sides in your base, and then just say, well, I also then have that many kind of vertical sides. So I've got the base plus however many sides the base has, lateral sides to count. Same thing over here. We've got, four different sides. So we better have four lateral sides to add to our base for a total of five sides. Let's do examples with these two. Okay, now in both of these shapes, we're going to have to do a little bit of intermediate work, and that might not always be true in all the problems you do, but let me explain some things that we're going to have to do here. The first thing is, remember on this first shape, we're going to have the base, and we're going to have the four sides. Now I made this an equilateral triangle, so that means each of these sides are also going to be the same. Now you can see I sketched in here that this has a base of 4 and a height of 9. So we could easily say, all right, the area of one side is the area of our triangle, 1/2 the base times the height. But just remember, we have 3 of those. So that right there, that counts up all 3 of those sides here, okay? That's not that hard to do. We just got to remember our triangle formula, 1/2 base times height, and then just remember we have 3 of them. But in this case, and I did this on purpose, I wanted to make the base a little bit harder to find, okay? This piece right here. So let me explain what we've got going on. We've got, if I can just kind of draw this, we've got an equilateral triangle, 4, 4, and 4. But we don't have the height of this triangle. And that's, our formula needs 1/2 base times height. Well, we can find the height on this, and there's definitely a formula out there for doing this because it's an equilateral triangle, because of the angle measurements, but I'm going to do this with Pythagorean theorem. I'm going to see in here that we have one right triangle, and it's got a hypotenuse of 4, and this side is 2, because it's half of that whole base of 4. So I can solve for this missing height by doing 2 squared plus the height squared using Pythagorean theorem equals 4 squared. Squaring the bases and adding them up will equal the hypotenuse squared. So squaring those things, subtract 4 from both sides, and then take the square root. The height is the square root of 12. Now that's a square root that I could actually reduce to be 2 square roots of 3. If you so chose to do that, I'm okay leaving it, but that's because I'm going to end up typing all of this into my calculator. So I already had my 3 vertical sides. Let me then add 1/2 base times my height for that base triangle. And again, you could have reduced that square root of 12, but to do base times the height. And then I could add these together. So there you can see I have typed it into my calculator. So we had to do a little work here in order to use our formulas. And sometimes that's the hardest part about surface area is we have to break out all of the regular area formulas and then maybe something else in order to get the measurements we need. All right, let's look at this other one that I've done. Now, first off, the easier part in this one is going to be the base because I made it a square. So it's just a 10 by 10, and I'm going to write this up here. We've got base times height, but of course it's the same. There's our base. Now, we have got 4 triangles, all the same, but we don't have the height of each of those triangles. We only have the height of the pyramid. But I have created inside here a right triangle. If I can kind of use my drawing here, that goes like this. So imagine, kind of a 3D kind of cut through there. But I have a right triangle that I could figure out the height of those kind of side triangles. So if the whole base is 10, this part just right here would be 5, just half of that. So now I could use Pythagorean theorem to figure out that hypotenuse. So let's do that. Let's say base squared plus height squared equals hypotenuse squared for that kind of that triangle cross section. Well, 25 plus 144, and that is 169 equals height squared. Square root of 169 is 13. So now I've got a base, remember we got to go back to the whole base, of 10 and a height of 13. So I could add up, let's do one triangle here, 1/2 the base times the height, and then just remember I have 4 of those. I use brackets here, but it's just the same as a parentheses. So that is the way I would figure out the surface area. Do the base, and then I had to use some Pythagorean theorem. And again, that's what can make surface area tricky, is you might have to, break out not only your area formulas, 1/2 base times height, but you might have to do some other work to even get to that formula. And there is our answer. So be very careful counting up the number of sides, and then be very careful using the correct area formulas and making sure you have the information you need to use them. If this video helped you, please like and subscribe for more geometry help.